Boys, today we're looking at absolute value functions. So yesterday we just looked at solving absolute value equations. Today we're looking at, well, what does a absolute value function look like graphically? And so we'll look at a couple of examples here. Just an encouragement, when you're doing your homework, just keep Desmos open and just graph loads of things so you get more and more familiar with what the equations look like and how they compare to what they look like graphically. Alrighty, so the absolute value function, what's interesting about it is that because we're thinking about absolute value, i.e. the distance from 0, means that that distance is always positive, and so if you've got an absolute value symbol, then it's going to make your function value positive for whatever you insert for x, like in this basic example here. And so what we get is this sort of V-shape graph. So we'll see some of these now. Alright, question 1. Let's have a look at that. It says sketch the graph of y equals absolute value of x and state its domain and range. Okay, so let's fill in this table of values just to get a sense of what it's like. Another way, of course, would be to find the intercepts and then just graph based off those. Alrighty, so if we put into our function y equals -3, -3 in the place of x, then that's going to become positive, so the value is just +3. So, and that will be the same for all those negative values, so 2 and 1 and 0 and then 1 and then 2 and then 3 as I sub those in. And so what we get is this cool sort of mirror image from the middle of the table going back in the positive direction, a bit like when we graph a parabola and we get that sort of mirror image shape, except this time we've got just x to the power of 1, so it's a straight line on each side. Okay, so if we plot those, then we've got -3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. Okay, so then we can just draw straight lines through those, and that will be our first function. It's not going to be pretty, but you get the sense of what it's going to be like. There we go. So that's the y equals the absolute value of x. Alright, so domain and range. You can see there that domain is going to be all real x, or negative infinity to positive infinity. So this is our stock standard domain and range. Domain. Okay, there it is, and our range. This time you can see, well, it goes down to 0, 0. That's the lowest point, and it includes 0, so it will be 0 with a square bracket up to positive infinity. Okay, that's question 1. Let's have a look at question 2. Okay, sketch the graph of fx equals absolute value of x minus 1. So what difference is that going to make? Let's have a look. Okay, so if we think about the last function, what that was, if we just subtract 1 off each of those values from the table, then it's going to be our correct values for y. So really just by adding a number on the end, we're just shifting the function, just like we would on a linear function, up or down the y-axis. So this is going to move down by 1. And so instead of this one, first one being at positive 3, it's going to be at 2. But I'll just show you that in a substitution anyway. So f of minus 3 is equal to, and then we've got absolute value of minus 3 minus 1. So that's going to be, this bit here will be plus 3 minus 1, which is equal to 2. Okay, so that means this is going to be 2, and that's going to go down by 1, so it'll be 1, 0, minus 1, and that's the point where it's going to start turning the other direction. So back up to 0, 1, and 2. So plotting those, it's now going to be at, that's where our point's going to be, 0, minus 1, and then it will head up in the positive direction there. Okay, domain and range, domain's the same. We've got negative infinity to positive infinity, and range, it's just shifted down 1, so negative 1 up to infinity. Fantastic. So the key thing in there is that a constant on the end shifts it up or down the axis. Alright, question 3. This time we've got our plus 2, or our extra value inside the absolute value symbols. Let's have a look at what difference that makes. So if we try our first value of minus 3 again, so what happens there? So we get y equals minus 3 plus 2, so that's equal to minus 1, absolute value minus 1, which is just 1. Okay, so we've got 1 there, and if we try minus 2, that's going to get us to minus 2 plus 2 is 0. Minus 1 will be at 1, and 0 will be at 2, and then you'll see continue 3, 4, 5. And so what's happened here is that plus 2 inside the absolute value symbol has actually shifted the function not up and down this time, but to the left. And so if it's a positive, then it's going to move it to the left. If there's a negative inside those absolute value symbols, then it would go to the right. Okay, so let's graph that. So minus 3, 1. Minus 2, 0. Minus 1, 1. 0, 2. 1, 3. 24, and 35. Okay. Wasn't great. Alright, so there's our function, just shifted this time 2 places to the left. We haven't asked for domain and range, but you can see there domain would be negative infinity to positive infinity, range would be 0 to infinity. Okay, last question, question 4. Okay, we're going to look at solving an absolute value equation, and we can do that graphically. So here's our example, solve 2x minus 1 equals 3 graphically. So another way to think about this is to think about the function y equals absolute value 2x minus 1 and draw that. Then see the value of where that is y equals 3 and find those intersection points on the graph. Okay, so rather than going for a full table of values, we can just see there if we've got the function y equals absolute value of 2x minus 1 and this function, it's not a curved one, it is a straight line. This function is like that one we just graphed, where it's just shifted left or right. So it's not moved up or down. So we can sort of be confident that where it's going to turn is on the x-axis. Okay, so if that's the case, then what we can do is find that point, and that's going to be at the point y equals 0. So the x-intercept y equals 0. And if we solve that, then we get x is going to be a half. Now, if we find the y-intercept, that's going to occur when x equals 0, and when x equals 0, you get y equals 1. And so this equation is going to go through a half and 1. And so if we draw it, it's sort of going to have a like a steepness of 2, and so for every 1 across, we're going to go 2 up. Okay, so just plotted a few points there. So if I draw that graph in, it's going to look something like this. And so what's the solution going to be? It's going to be at where y equals 3. And so if I draw in a line for y equals 3, straight across there will be the 2 intersection points. Oh, geez, that's adjusted way off. So that's not a great graph. So check out this one. Here's a graph on Desmos, and there are your 2 solutions. Good luck with your questions.